Okay, this is lesson 7.5, solving exponential and logarithmic equations and inequalities. In part A, for example 1, we have 8 to the x power equals 2 to the x plus 6. Now 8, the number 8, is a power of 2. So I can write this as 2 cubed raised to the x power equals 2 to the x plus 6 power. Now I use my power to a power property, and so this is 2 to the 3x equals 2 to the x plus 6. So now both sides of my equation have a base of 2, and when this happens, when the base is the same for both sides, like this, you can drop the bases. And I'm allowed to establish the equation 3x is equal to x plus 6. Subtract x, we get 2x equals 6. Divide by 2, x equals 3. Now we have a solution. So, okay, let's go ahead and check that solution to make sure that it all works. So I'm going to put 3 into this, and I get 8 to the third power equals 2 to the 3 plus 6. So now the question is 8 to the third power the same thing as 2 to the 9th power? That's what we want to answer. Yes. So we have found the solution. So some equations you'll be able to take one side, and one side can be written as the other base to a certain power. 8 is a power of 2. But problem B is a little bit different because 200 is not a power of 5. Okay, what do you do when that happens? Well, what you do when that happens is you take the common logarithm of both sides. So what I do is I apply the common log to the left, and I apply a common log to the right. And so it looks like this. Common log of 5 to the x minus 2 equals common log of 200. Now I use the power down property. And so x minus 2 times the common logarithm of 5 equals the common logarithm of 200. Now let's divide both sides by the common logarithm of 5. So common log 5 dividing here, common log 5 dividing there. This divides away. This now leaves me with x minus 2 equals common logarithm of 200 divided by common logarithm of 5. Add 2 to the other side, and I get 2 plus common log 200 divided by common log 5. And this is the exact answer. But I want to check this, so I'm going to find the approximate answer. So that's 5.292. So I'm going to say about 5.29. Go ahead and try these 3 problems on your own, and then I'll give you the solution. So go ahead and pause the video now. Here are the solutions to 1A, 1B, and 1C. Here's example 2. Let's say you're taking a contest, or you're part of a contest. You can choose one of 2 prizes. Prize 1 is a brand new car valued at $20,000. Prize 2, you get a penny one day, or on day 1. One day on day 2, it's doubled, so you get 2 cents on day 2. And so on for each day after it is doubled, you got the day before. So on day 3, it would be 4 cents. On day 4, it would be 8 cents, and so on and so forth. This happens for 1 month, 30 days. How many days will pass before prize 2 becomes more valuable than prize 1? And the question is, when does that value become less than a penny, which is 0.01, doubled every day? So that would be 2 to the d minus 1. And the reason why it has to be d minus 1 is because d equals 1 is the first day, and you only get a penny on the first day. So that would be 0.01 times 2 to the 1 minus 1. And 1 minus 1 is 0, so that's 0.01 times 2 to the 0. 2 to the 0 is 1, and so 0.01 times 1 is just 0.01. That's 1 penny. On the second day, it's doubled, so 2 minus 1 would be 1. So 2 to the 1 is 2, so you'd have 2 cents, and so on and so forth. So let's solve this inequality. First thing we're going to do is we're going to divide both sides of this inequality by 0.01. And that's going to add 2 more zeros to my number here. So now that's 200,000 is less than 2 to the d minus 1. Now 200,000 is not a power of 2. So I'm going to take the common log of both sides. So this is common log of 200,000 equals common log of 2 to the d minus 1. Now I use my power down property. And so this is d minus 1 times common logarithm of 2 equals the common logarithm of 200,000. Let's divide both sides by common log 2. So d minus 1 equals logarithm, common logarithm of 200,000 divided by common log 2. And let me talk about a mistake that people usually make when they're first learning how to solve logarithmic equations. This is a logarithm divided by another logarithm. So what you can't do is you can't divide this 2 into the 200,000. That would violate the order of operations. Now the exact answer is I would add 1 to the other side, and I would have 1 plus the logarithm of 200,000 divided by the logarithm of 2. Well, let's go ahead and calculate that. That's about 18.6, which is about day 19. So after 19 days, the value of prize 2 actually becomes worth more than the value of prize 1. Now, if there are 30 days in that month, you still have 11 days to go. So if I actually take 0.01 and multiply it times 2 to the 30 minus 1, that would be 0.01 times 2 raised to the 29th power, 5,368,709.12. Here's a try it on your own question. Suppose in prize 2 you tripled the amount each day instead of doubling the amount. On what day would you receive at least $1 million? Go ahead and pause the video and try this on your own, and then I'll give you the answer. So on about day 18, you would exceed $1 million. Technically 17.76, but that's more than 17 days, so we'll say about day 18. Example 3, let's solve each equation. So for part A, what I'm going to do is I'm going to convert this into exponential form. So I'm going to say 3 squared equals x minus 5. 3 squared is 9. And then I add 5 back over, and I get 14. Now, every single time you solve a logarithmic equation, you need to check your answer. You need to check your answer every single time you solve a logarithmic equation. And we're going to see why that's the case in part D more than anything else. So I'm going to take 14, I'm going to plug it back in. So this is log base 3 of 14 minus 5 equals 2. That's log base 3 of 9 equals 2. And if I translate that into an exponential equation, 3 squared equals 9. It checks perfectly. Part B, I'm going to use my quotient property. So the logarithm of 45x minus the logarithm of 3 becomes the logarithm of 45x divided by 3. Well, 45 divided by 3 is 15. So this becomes the common logarithm of 15x equals 1. Now let's convert this into exponential form. This is base 10, so 10 to the 1 equals 15x. And now I divide both sides by 15. That's 10 over 15, which is 2/3. And so my answer is 2/3. And now I'm going to check that into the original. So the logarithm of 45 times 2/3 minus the logarithm of 3 equals 1. Well, the logarithm of 45 times 2/3 is the logarithm of 30 minus the logarithm of 3. This becomes the common log of 30 divided by 3, which is the common logarithm of 10. But common log 10 is the number 1, and so 1 equals 1, and it checks. All right, let's go ahead and move on to the next one. I'm going to convert this directly into exponential form, so 4 to the 7th power equals x squared. Now, what is 4 to the 7th power? That's going to be a big number. 4 raised to the 7th power is 16,384 equals x squared. Now I use the square root property, and when I do that, I have to take both the positive and the negative square root. So the positive and the negative square root, x equals plus or minus 128. Now, for part C, both of these answers work, because if I take the logarithm base 4 of negative 128 squared equals 7, I actually have to square the negative 128. So negative 128 squared is 16,384. So that's the logarithm base 4 of 16,384. And so 4 to the 7th equals 16,384. And I can check that directly on my calculator. So for part C, both of the answers work in this case. Again, I don't want to harp on this, but I really feel like I can't say it enough. Whenever you solve a logarithmic equation, you need to check your answers. You have to. Okay, so D, I said, is the one where we're going to find out that we have to check it the most. Okay, let's go ahead and solve D. So for D, I'm going to use my product property. So because I have the sum of two logs, this becomes the logarithm of x squared plus 9x equals 1. Now we convert this to exponential form. Logarithm is base 10. Common log is base 10, so x squared plus 9x equals 10 to the 1, which is just 10. Subtract 10 to the other side, and I've got a quadratic equation. So I either have to factor this, or I have to use the quadratic formula. Well, turns out factoring is the way to go this time. X plus 10, x minus 1 equals 0. Now I use my zero product property, so x plus 10 equals 0, and x minus 1 equals 0. So x equals negative 10, and x equals 1. Now again, we have to check both answers. So I'm going to check 1 first, and when you check your answer, you need to plug it back into the original equation. Nothing after that, the original. So this becomes common log 1, which is 0, because 10 to the 0 is 1, plus common log of 1 plus 9. So logarithm of 1 is 0, 1 plus 9 is 10, and common log 10 is 1. So 1 equals 1, so this solution checks. Now let's plug negative 10 into the original, and we have common logarithm of negative 10 plus common logarithm of negative 10 plus 9. And already there's a problem because this part of the logarithm, you can't put a negative number inside the logarithm. It doesn't make any sense to have logarithm of negative 10. This would become logarithm of negative 1. It still wouldn't make any sense. So the negative number cannot go inside of a logarithm. Whatever goes inside the logarithm has to be greater than 0. So that means that 10 is called an extraneous solution. Extraneous. Well, an extraneous solution is no solution at all. We reached outside our domain for the solutions for this. So the only solution, the only true real solution to this problem is x equals 1. Go ahead and pause the video and try to solve both of these questions, and then I'll give you the solution. Okay, here's the solution to the problem. For 3a, the solution is x equals 5. For 3b, the only solution to this problem is x equals positive 2. Negative 2 does not work. So, okay, for example 4, what I want to do now is I want to solve the equation 2 to the 2x is equal to 1024. So in y1, I'm going to type out 2 to the 2x. And in y2, I'm going to type out 1024. And particularly, I want to use my table feature to solve this. So let's go ahead and let's do that. So what I'm going to do first is I'm going to go to second table set. I'm going to start at 1. I'm going to go in increments of 1. And let's keep the independent and the dependent on the auto feature. Let's go to second table. And we can see right there what the solution is. X equals 5. So we have the solution to the problem. So, okay. We have that. Let's do the next part. Let's clear these out. Now this next one is going to be an inequality. So what I want to do is I want to figure out when the common logarithm of x minus the common logarithm of 2 is less than or equal to the common logarithm of 75. So I'm going to do this graphically. I'm going to go to Window. I'm going to let x min be 0. My x max Turns out this x value is going to be rather large, so I'm going to go up to 200. My x scale is 10. My y minimum is 0. The y values do not get very large, so my y maximum in this case will be 3. So the blue curve represents logarithm of x minus log 2, and the red curve is just the logarithm of 75. It's a constant. And again, I want to know when the blue curve is less than or equal to the red curve. So I want to figure out what this point is here. So I'm going to use the intersect feature of my calculator, option 5. And even though I don't think I have to in this case, let me put the cursor close to the answer. Now I'm going to hit enter again, hit enter again. 150, 150. So, okay, remember how this works now. Here's logarithm of x. The argument of the logarithm can't be negative, so that immediately means x has to be larger than 0. But 150 is where they meet, so x has to be less than or equal to 150. So the solution to this is 0 is less than or equal to x is less than or equal to 150. All right, let's go ahead and clear those out. Let me give you the following equation. 2 raised to the x, and then equation 2, 4 raised to the x minus 1. Now, can you figure out when these two graphs are equal? For what value of x will these two graphs be equal? See if you can use your calculator to solve that. So go ahead and pause the video now. Okay, the answer is they are equal for x equals 2. They are equal for x equals 2. Second question, can you figure out when 2 to the x is less than, not less than, when it's greater than 4 to the x minus 1? For what values of x is 2 to the x greater than 4 to the x minus 1? Go ahead and pause the video and try that now. The solution is for all values of x less than 2. So x can be a negative number. So negative 1 works, 0 works, 1 works, 1.99 works, negative 5 works. The solution is x is less than 2. All those numbers work. Last question. When is the common logarithm of x squared equal to the number 6? Go ahead and pause the video and see if you can find the solutions to that. Okay, answer. When is the logarithm of x squared equal to 6? This has two answers. One of the answers is positive, make sure I get this right, 1,000. And the other answer is negative 1,000. X min, I'm going to let my x min equal negative 1,500. I'm going to let my x max be 1,500. My x scale is going to go in terms of 100. My y minimum is 0. My y max is 7. There we go. So this intersects here. Let's find out where. At 1,000. And over here, this intersects at negative 1,000. And that is the lesson. God bless you, wherever you are today.